One other thing I forgot to do with that last problem was to answer the question. So what was the question? The question again was, how fast is the radius of the balloon increasing when the radius is 6 inches? Okay. So given the calculations that we did and that we ended up with, we can answer this question in a complete sentence. We can say the balloon's radius is increasing at a rate of 1/9 pi inches per minute. If you wanted to, if you were asked to, you could find a decimal approximation of 1/9 pi. I'm not going to worry about that right now. Okay. It is important with word problems to be able to answer them in complete sentences because it shows that you're correctly interpreting what's happening and that you understand how to present the final solution and interpret it. Okay, here's some general steps for related rates problems. And we did some of this, well, all of this already. I just want to reflect back and show you what we did. So we read the problem carefully. The sketch was already provided for us, but as I mentioned, you're going to have to probably make the sketch yourself in a lot of cases. Make a sketch to organize the given information, identify the rates that are given and the rate that is to be determined. So those are all the things we did. Those are the little questions that we broke our solution down into. Introduce rates of change by differentiating the appropriate equation. So we had to, for that last example, we had to think of a geometry equation and we had to remind ourselves of that with respect to time t. Then substitute known values. And remember, we took a moment to identify what do we know and where should we plug it in. And then we solved for what we were being asked to solve for. That last sentence that we just went over kind of addressed this one. Check that units are consistent and the answer is reasonable. We wanted to make sure that a radius changing has the units inches per minute since the volume was inches cubed per minute. So the other part, the other part we didn't talk about yet was, does it have the correct sign? If we look back, the question is saying, how fast is it increasing? When we say increasing, we associate that with a positive derivative, okay? And when we get to chapter 3, we're going to really emphasize a lot the fact that a positive derivative means increasing and a negative derivative means decreasing. And the nice thing here is that our derivative, our final answer, was a positive number, and the problem's asking for the increase, the rate at which something is increasing, which means everything is consistent, everything makes sense. So we're pretty happy about that. That's an important step to double check. Okay, so those are the steps for related rates problems. Just to go back to that question of increase and decrease, similar question here. You have a spherical balloon expanding given that the radius is increasing at the rate of 2 inches per minute. At what rate is the volume increasing when the radius is 5 inches? So now they're giving you the rate of increase of the radius, and they're asking for the rate of increase of the volume. Okay. Again, we would, for this one, we would do v equals 4/3 pi r cubed. We'd take the derivative of both sides, which, as we did before, it ended up simplifying to 4 pi r squared dr dt. Details of that are in a previous video. And we know that the radius is increasing at a rate of 2 inches per minute. That means dr dt is a positive 2. I'm going to put a plus 2 in parentheses to really emphasize the fact that dr dt is positive. And then it's asking at what rate is the volume increasing? So we don't know what dv dt is. We're trying to solve for it. So I'll just write dv dt again. When the radius is 5 inches. So radius 5 inches, radius is r, which means I'll plug in 5 for r. And I'll copy all the other stuff I haven't dealt with. So we get that dv dt will be 200 pi, and then what's our units? Well, it's volume and the radius is inches and our time is minutes, which means our units for volume will be inches cubed per minute. Okay. The follow-up question to that is, what if the radius is decreasing at 2 inches per minute? Okay. We'll copy this equation since it'll start the same way. And then when it says decreasing at 2 inches per minute, what we think is dr dt is going to be negative 2 inches per minute. Because again, we associate a negative derivative with decreasing. All right, so if I plug everything in that I know, it'll be a little different from before. The radius will still be 5 inches, so I'll still plug in 5 for r. dr dt will now be negative 2. And so the volume will decrease at a rate of 200 pi. So decrease, which means I should put a minus sign there, at a rate of 200 pi inches cubed per minute. How do we answer that in a sentence? Well, in the equation, the negative sign tells us the decrease. But in the sentence, the word decrease tells us the decrease. So we don't want to say that something is decreasing at a rate of negative 200 pi inches cubed per minute. That's redundant. We're reflecting decrease twice, so that doesn't make sense. What we should say then is that the volume, in this case, is decreasing at a rate of 200 pi inches cubed per minute. The sentence for this problem would have been the volume is increasing at a rate of 200 pi inches cubed per minute. Okay, I want to really emphasize why these two numbers are exactly the same. Why in this sentence did I not put a negative sign on the one with its decreasing? Okay, it's because the word decreasing is the same as the negative sign we got in our work over here. So when I say it as a sentence, I should say it this way. The volume is decreasing at a rate of 200 pi inches cubed per minute. And then if I wanted to know what dv dt is, I have to make sure that I write dv dt as a negative quantity. Okay. Let's do some more examples.